Hi everyone, this is me Basim and welcome back to my channel. So today in this video we are gonna solving this math question. This question is from May-June 2024 paper 3-2. This is the recent question paper. So let's begin. The equation of a curve is y e to the power 2x plus y square e to the power x is equals to 6. Find the gradient of the curve at the point where y is equals to 1. So after reading the question, we have analyzed one thing that we need to find the gradient of the curve. Basically, we need to differentiate this equation of a curve to find the gradient of the curve. And over here, you can clearly see the value of y is given, or the y coordinate is given, which is 1, but we don't have x coordinate. So how we will find the x coordinate? We just need to simply insert this value of y, which is 1, directly into the equation of the curve to find the x coordinate. So let's do this. Y e to the power 2x plus y squared e to the power x is equals to 6. So it will become 1 e to the power 2x plus 1 square e to the power x is equals to 6. It will be e to the power 2x plus e to the power x, and let's take 6 on the other side. It will be minus 6 is equals to 0. Now basically e to the power 2x is exactly same e to the power x whole square. So these both are the same thing. So let's replace e to the power 2x with e to the power x whole square. So it will be e to the power x whole square plus e to the power x minus 6 is equals to 0. And let's suppose if I take e to the power x is equals to u, over here I just basically substitute e to the power x with the letter u. You can use any of the letter you want, but for this case I use the letter u. So it will be u squared plus u minus 6 is equals to 0. So now you can clearly see over here, this is the quadratic equation. So let's solve this quadratic equation with the factorization method. It will be u squared plus 3u minus 2u minus 6 is equals to 0. Now let's take the u common. It will be u plus 3. And over here, let's take minus 2 common. It will be u plus 3 as well is equals to 0. So it will be u plus 3 and u minus 2 is equals to 0. It will become u plus 3 is equals to 0 and u minus 2 is equals to 0. So the value of u is minus 3 over here and the value of u is 2 over here. Now let's replace u with e to the power x again. So it will be e to the power x is equals to minus 3 and e to the power x is equals to 2. Let's see if I draw the graph of e to the power x. So it will somehow look like this. Now this is y, this is x. So yeah, this is basically the graph of e to the power x. So now let's focus at this part of the graph. Over here, you can clearly see the graph of e to the power x is basically parallel to the x-axis. So one thing is clear, that this e to the power x graph will never intersect the negative x. So as the graph of e to the power x will never intersect the negative x-axis, so this e to the power x, which is equals to minus 3, it will have no solution. So only this value of e to the power x, which is equals to 2, it will only be considered. This value of e to the power x, which is 2, and the other value, which is minus 3, will not be considered, as the graph of e to the power x will never intersect the negative x-axis. And as we move forward, it will be parallel to the x-axis. So it will become x is equals to log of base e 2 and x is equals to ln 2. Basically, this is the value of x or the x coordinate at which the value of y is 1. So the whole coordinate will be ln2, comma 1. The value of x coordinate is ln2 and the value of y coordinate is 1. So let me write the equation of the curve onto the separate page. Y e to the power 2x plus y square e to the power x minus 6 is equals to 0. So this is the equation of the curve. Let me explain you the basic rule of differentiation. So over here you can clearly see one term is multiplying with the other term. Over here the y is one term and the e to the power 2x is basically a separate term, and both of these terms are multiplying with each other. Same with this case as well. So we have analyzed that we need to apply the product rule of differentiation. And the product rule of differentiation is basically d over dx is equals to v u dash plus u v dash. This is the basic rule or the product rule of the differentiation. And let's suppose if there is a value of y and we need to differentiate that value of y. So d over dy is equals to y, and we need to differentiate this value of y. So how we'll differentiate this? It will become 1 dot dy over dx. So over here for this case, dy over dx will be multiplying with the value of 1. So this is the basic rule to differentiate the value of y. So over here, first of all, let's identify the value of u and v respectively. So the first term over here, it will be u, this will be v, and same for the other case as well, it will be u and it will be v. So first of all, find the value of u dash and v dash for the first case. So u dash will be 1 dot dy over dx. And v dash will be e to the power 2x dot 2. So now it will become 2 e to the power 2x. And let's differentiate for the other case. Value of u dash will be 2y dot dy over dx, and the value of v dash will be e to the power x as it is. And the differentiation of minus 6, as you all know, will be 0. So now let's insert the value of u dash and v dash respectively into the product rule formula. So let's apply the formula. Basically, for the first case, we need to apply this product rule formula, which is v u dash plus u v dash. So over here, the v value of v for the first case is e to the power 2x. So it will be e to the power 2x multiply with u dash. U dash is dy over dx plus now u and v dash. So u over here is y and v dash over here is 2 e to the power 2x. Plus now let's apply this product rule formula for the other case. So for the second case, v is e to the power x. V u dash is 2y times dy over dx. V u dash plus u is y squared, and v dash is e to the power x is equals to 0. So now let's replace e to the power 2x with, over here you can see e to the power 2x is basically is equals to e to the power x whole square. So let's replace this. It will become e to the power x whole square times dy over dx plus y times 2 times e to the power x whole square plus e to the power x as 2y times dy over dx plus y square as it is, and e to the power x as it is equals to 0. So basically e to the power, over here you can see e to the power x is equals to 2 and the value of y is 1. So over here, e to the power x is basically is equals to 2 and y is equals to 1. Now let's insert these values, e to the power x is equals to 2 and y is equals to 1 directly over here. So it will become 2 whole square times dy over dx plus y is 1, 2 as it is, and e to the power x whole square is basically 2 to the power 2 plus e to the power x 2 again, then 2 times 1 as the value of y is 1, then dy over dx plus 1 square and e to the power x is 2 is equals to 0. It will become 4 dy over dx. It will become 8 and it will become plus 4 dy over dx and it will be plus 2 is equals to 0. So now add both of these 4 dy over dx plus 4 dy over dx, it will become 8 dy over dx and 8 plus 2 is 10 is equals to 0. Now let's take 10 to the other side, it will be 8 dy over dx is equals to minus 10. Then dy over dx is equals to minus 10 divided by 8. It will be 2 4s are 8 and 2 5s are 10. So dy over dx is equals to minus 5 over 4. So this is basically the final answer of the question. Dy over dx is equals to minus 5 over 4 at the point where x is equals to ln2 and y is equals to 1. I hope that everything is clear to you. If you have any doubt, so let me know in the comment section. So yeah, that's all for now. We'll meet in the next video. Till then, take care. Goodbye.